Hello all and welcome back. So in this video, let us now continue our discussion and now let's see how can we implement our tree in our code. So let's get started. Now in the last few videos, we learned a lot about tree, where they can be used, as well as what are the different terminologies of my tree. So to understand a tree, what we can do is let us first draw one. So my tree I know is going to be something like this. So we have a overall root node and then my root node can have multiple children, right? So let me draw it like this. Great. So now let us talk about what exactly or how exactly can we define a node of my tree. So effectively, I am saying that this one, which we see in the terminologies as well, this is a node of my tree, right? So let us now understand that how exactly or what are the different things which my node should have. The very first thing which I think should be there is the data of my node, right? So all these nodes, they will be having some data, let's say 1, 2, 3, and 4. I have to make sure that I'm able to store that data just like we did in linked list, right? So let us move to code and understand how exactly can we do it. So let's say a class tree node. That's what I'm saying, each and every node of mine. So the understanding and the idea is actually the same. That just like in my linked list, I was creating nodes and I was connecting them based on my use case. Similarly, here as well, we will be doing the same thing. Now, since I have already told you that how our tree is a primary data structure, we have to define each and everything here. Unlike in stack and queues, where we were able to use list or linked list in the backend, right? So the very first thing, let me create a constructor init self, and let's say we will be getting the data as well, right? So self.data is equals to data. Great. So this is the very first thing which we have defined, everyone. Now the next thing which I feel each and every node should have is the information of its children, right? This information of children will actually help my node to say that, hey, these are my children. Can you please go and retrieve them or do some work on them? That is how they are connected, right? So second, I can say that I have this children's, right? Now I can either use and not children's, it's already plural, child and children. So now I can either use a list or a linked list for this, right? So two majorly we have seen that these are the two data structures which we can use for it. First, let us talk about linked list. The problem I feel in linked list can be that yes, we can store our children in them. So let's say we can create a linked list like this. Okay. But to actually access any particular children, let's say if this has 10 children, to access the fifth children, I will have to start from it and then go towards that fifth children, right? Now the same can be the last children as well, or rather the second last one, because last many of you might think that tail can handle that, right? So let's say if I have head here, then I can maintain a tail for last children. Well, the problem is I have to even access the middle children as well, right? So, and it can have numbers of these children. It is not that it will just have two, three, or four. So, I'm talking about a generic tree here, right? We can have any number of children. So, better overall is a list in this particular scenario because of its offering of indexing and the dynamic nature. So, we know that we can have many children as we want, and dynamic nature will handle that. When we are discussing about the same in other languages, like for example, let's say C++, where I told you that how array is a predefined size, basically data structure, right? So we cannot change the style. We also try to use dynamic array there, right? Because we want that indexing, we want to access the middle children as well, right? So for this particular use case, I personally believe that we can go forward with the list because we have the benefits of indexing as well as the dynamic nature of my overall list here. And these are all the children's, right? So these are all the children which I can now store in this particular children data. So let us define this as well, everyone. Self dot children, and by default it's going to be an empty list, right? So that is what I've said. Now I think using this tree node, I should be good to define my tree. Like I can connect these tree to each other, and we should be at a good place to now, in a way, say that hey, this is a tree which I have made based on the understanding. So now let us move forward, everyone, and try to define basically root and everything. So we will be creating a root, okay, which can be say tree node with one, okay. Then let us make three children. So children one, sorry, child one, which is going to be equal to tree node two, child two, it can be tree node three, and child three, tree node four. So I'm just drawing the same tree, everyone, the tree which we are seeing in front of us. The understanding again is as of linked list, each and every one is a tree node. So again, they can have their own children when we move forward. For the time being, what I will have to do, I have to make sure that I'm able to add children to my root, right? This is one is my root, right? And I have to add these three children to it. Now, where am I actually maintaining these children? This is in this particular list. So what can I do? Root dot children dot append. I can add child one here. Root dot children dot append child two, and root dot children dot append child three. Okay, so now actually I have created this root node, this one, and in this I have added three children. Because these nodes are not having any child, so of course I'm not doing that, right? I'm not doing that. Uh, the way we can see that, so maybe I can just print for the time being. We are going to see how we can effectively, of course, make sure that we can effectively print our tree to see it properly. One second. So it is showing their addresses, right? So children of, if I do 0, so here we are storing these addresses, which makes sense. So this in this children, we are having multiple nodes. So I will have to write data here in top in front of this, right? Because each of these is a node of my root tree node type, and this is having a data. Now we are seeing two. Okay. So I hope each and every one of you are able to understand one. So if I can draw, let me explain how exactly it would have happened. We have this one node. In its children, we have 2, 3, and 4. And thus this connection is getting made. Ideally, it will not be like this. The children will have this connection. So I will help you visualize that as well, so that no problems are there. But yeah, this is what I'm saying. This is an empty, this is an empty, and this is an empty. This is how, in terms of my data tree node which I have drawn, the tree will be in the memory. These connections, it will not be to my roots, but rather to this. And my root will have access to this thing. Okay. So to understand this a lot more in depth, let us do one thing. Let us try to visualize the same in Python tutor. Okay, so I've just put up my code here. Now let us visualize it. Again, it's not going to be a lot intuitive, or I would say clear, as it was in linked list. Okay, so let me just remove this. Yeah, great. Let us see. Cool. So we are defining the tree node. Okay. Again, as I was saying, it is not a lot clear as it was in linked list, but yes, we will still be able to see. Going forward for complex trees, we might not be able to see a lot better here. So for that, I will use a different visualizer so that you are able to actually see everything, as well as we will be drawing the same. Okay. So let's see, everyone, root. Okay. So I'm creating a root, which is created by tree node. As of now, this root is having children, which is empty, and data, which is 1. In a similar way, I will be creating children, child 1, child 2, child 3. So till now, the second I have just created these childs, right? Till now, they are just created in the memory. They have no relation whatsoever with each other. As of now, it is just that I have allotted some space in my memory for these 4 nodes. Okay. So we started with 4 nodes. There are 4 nodes. Now to connect them, to connect them is where I will be using this children list. And how I'm saying that, hey, in your children, please add these as your children. So you will see how they get added. See. Now let me just remove these one so that you are able to better see this. So it's not going to be a lot hierarchical the way we imagine it, but yeah, great. See now. And this was the reason. So we just saw that how they were connecting to the same overall this particular node. Now you will be able to see that, hey, this is my child root node. Okay. You can just forget them for the time being. I can even delete them. Again, the understanding of linked list is going to be a lot helpful here, right? So one, I have this children, this overall child. This, I have this child. And zero, sorry, for two index, I have this child. And each of these nodes, they have their children as empty. If I want to add a children to my two, for example, if let's say this is in a way saying that, hey, one, we have two, three, and four. Okay. So two, three, and four. Two, three, and four. They are empty as of now. Okay. If let's say I would like to add a 5 as a children of 2, then I will just add in this particular list, in this empty list, I will make sure that I add a 5 here and we will get a node as 5. Okay. So yeah, pretty sure that would be understandable. We are just making the connection the way we did in our linked list. So I'm pretty sure that all of you must have done the linked list module as of now. If not, then please make sure that you see that. Okay. So this way, yes, we are able to define our tree in the memory. We are able to join that, and everything which we discussed, right? We are able to do the same. So great, everyone. I hope you are able to understand this. Just one more thing I would like to show you. Okay, so I have that code written on the same side. One second. We can actually define our overall code like this as well. So let me make sure that we are able to see that. Edit this code. So we can have the like this. Root can be TreeNode, CEO, head of sales, head of marketing, sales executive, okay, and then marketing executive. So I'm just passing a different data this time, and then I can add all these as a children of my CEO, where I am saying that, hey, you all report to CEO, right? So just adding this is something which we have to do, nothing else. Okay. So yeah, that is something which we can of course do. Uh, I think that this example will be a lot more intuitive and easy to understand that how under my CEO everyone is working. So again, I will be making a CEO. Here again, if we want, we can change them to reportees instead of children, but I think children works fine because this is the basic structure which is going to work everywhere. Now I can have head of sales, right? Head of marketing, sales executive, and marketing executive. Something like this. Again, we can have them at any level. That should be fine. But yeah, this is the kind of data which we can also draw using this, what we have drawn. So you will be seeing that how all our understanding which we had for the last few videos, we are able to transform into code very easily. Okay. Cool, everyone. So let's meet in the next video and see how we can print our tree very nicely so that, of course, we don't have to resort to this visualization every time because that will not be feasible for a larger tree, right? Thank you.